Good afternoon, ladies and gentlemen. Let's get ready for a thrilling journey into digital transformation. In this section, please join us as we are exploring how ABN AMRO discovered their strategic migration. The Databricks solution also involved and how their data evolution led to impressive scale and speed. Let's put our hands together to welcome our pioneers to the stage.
That side.
Good afternoon, everyone, and thanks for joining this session today. My name is Marcel Kramer. I brought with me Rakesh.
Good afternoon.
He's the domain architect for data in ABN AMRO, and I'm heading the data engineering team in ABN AMRO. And we want to talk a little bit about what we did with our data landscape, and actually to drag you in and to draw your attention, we said how we killed our data warehouses, because we really moved from a different paradigm to where we are currently. But it's also actually a story about how to modernize your data landscape, what to keep in mind, what to do, what not to do, and how you basically move from an on-premise situation to a cloud setup. So we're going to take you along. But first, I want to just introduce you a little bit into ABN AMRO. Some of you might know ABN AMRO, some of you might not know ABN AMRO, but ABN AMRO is a Dutch bank with a focus on personal business banking, wealth management, corporate banking. We're located in the Netherlands and we have a focus on northwest of Europe. We have around 20,000 people working worldwide and we have an operating income of 7.8 billion euros, just to mention a couple of facts. A couple of countries you can see on the slide where we are present. And we have a strategy called Banking for Better for Generations to Come, and it consists of three main pillars, basically. And it's good to keep those in mind. I'll get back to you why that is, but it's about our customer experience, really reinvent our customer experience and that they really find that they're doing business with a digital company. The second one is about sustainability. We truly want to move our customers into a next sustainability level, so we want to help them get to, for example, a better house where they have a better energy setup and footprint and whatnot, these kind of things. Also for corporates, we want to help them into a better sustainable setup. And ultimately, we also want to create a future-proof bank, a safe company to be with, to work with, and that we are ready for the future. And actually transversal through those three strategic pillars is data. And we really recognize data as one of our key assets. And I think we also heard that this morning in the keynote sessions that you can really differentiate yourself with data. And we truly appreciate the value of data. But data is as good as how you can turn it into value. So it starts with having the right data, then you can maybe take some decisions based on the data. Decisions lead to actions, and actions ultimately drive the value that you can generate with data. And we tend to look at data along two axes, basically. So you have an offensive way to deal with data and a defensive way to deal with data. The offensive way is something quite new for a bank. The defensive way is traditionally what we always done. So you want to have a mortgage with the bank. What's the first thing that the bank is asking? They want you to deliver a lot of paperwork, a lot of data points, so that the bank is able to assess the risk related to providing you a mortgage loan. And that's on a kind of a micro level. On a macro level, we're aggregating those data points into all sorts of risk models that allow us to predict a little bit like what is the risk we run on interest rate hikes or liquidity positions that we have, what happens when there's a bank run and whatnot, those kind of things. That's kind of the defensive way of how you can work with data. But there's also an offensive way, and that's kind of more using data as an asset to, for example, explore new business models. You can think about marketing purposes, but you can also look into what kind of new things can you achieve by using the data that you have. And we have millions of transactions a day that are quite rich in terms of what kind of metadata they have and what kind of insights you can gain from that. So suppose, if you all recall, of course, COVID situation, our transaction data that we saw on a daily basis gave us a lot of insights in what we could do with that data. Just to give an example of how you can, in an offensive fashion, work differently with data than just protecting your assets in a defensive way. Now, data is important, and the way we want to really turn data into value is along a value chain. And the three main buckets that we have in a value chain is we start with making fit-for-purpose data. You can all imagine that if you have bad data, you will never be able to achieve some good results, some real value with data. I always have to laugh about the example which I recently learned. Maybe a guess, who is our oldest client based on our systems? Just shout. Our oldest client. How old is that person? Avilash, do you know it? 250 years old. Now, well, it's registered in the year 0001, so it's 1 year older than Jesus. So, and that's in our system. So if we don't fix these things, then things downstream obviously go very wrong. So we have to ensure that our data is fit for purpose. And what we mean with that first bucket is we have to make sure that the data quality is right, that there's no data gaps, that data issues are being tackled. The second one is once the data is good in quality, you need to be able to get rapid access to authorized data. So rapid is about the speed, and authorized is about governed data. So data owners need to allow you to work with the data. They need to be able to take ownership of the data and say and approve when it's allowed to work with the data and when not. That's the middle bucket that we see, rapid access to authorized data. And only then you can accelerate data-driven decisions. So we do not use data, again, as I said before, just to protect our assets, but we really want to drive automated decisions. So if you go back towards our strategic pillars, a true customer experience, working or having a relationship with a digital bank is also about expectations that you have a different way of interacting with your bank, also driven by data. Now we have therefore set up a new architecture already in 2017. We started to introduce this architecture where we clearly separated data providers from data consumers. And there's two layers in the middle part. That is where we distribute the data. It's about having data discoverable. So the discoverability of data and working with data based on metadata is something that is really important to really ensure that you govern the data properly. So we have set the vision for creating a data marketplace where you can find the data, where you can ask for access to the data, where data owners can grant you access to the data. You will see the data quality of data sets. You will see if it's a golden data set or whether it's a non-golden data set. So what is the record that you need to look into and what is kind of derived record, if you like. So that's kind of on the top. That's what we call the data marketplace. And underneath that, there has to be a mechanism on how you exchange the physical data. How do you ensure that if you have data sitting in a providing system, how is that going to be ending up in a consuming system? What kind of mechanism do we have? And for that, we have set a digital integration and architecture layer, access layer, sorry, and that is kind of the way we distribute data and how that is being set up. Now, a couple of artifacts or a couple of capabilities that we have defined in our future state architecture you will see on this slide. So we have, like I mentioned before, we have the digital integration and access layer. That is basically the way we exchange data from A to B. I'm going to further dive into that later on. We have domain data stores, so once you have the data that you want to work with, in most cases you need to integrate that data based on the business logic that you, for your specific data domain, have. So you want to exclude data, or you want to merge data, you want to integrate it along certain business logic. You need to have a system to be able to do so, and capabilities to do that work. That's what we call a domain data store. And then once you have integrated that data, you want to do something with it. You want to create an analytics model, you want to explore the data from as a business analyst, and you want to do it in such a way that you do not create shadow IT. You want to maybe create your own BI reports or dashboards, or you want to allow IT teams to create a recurring report that every now and then needs to be updated with a certain frequency. And in the middle, of course, you will see the value is changing once you move up the chain, right? So you have looking back, what happened, why did things happen, what is going to happen, can we support a decision, or can we ultimately take automated decisions based on what we see in the data. So those are the major data capabilities that we have put on paper. But this is all very nice and well. This is paperwork, this is PowerPoint. And yes, of course you see PowerPoint here, but this is where we were at some point in time, and then some triggers started to kick in on we need to now start to also bring this in practice, and that is where the difficulties come in. And I think that is also something that you might start to appreciate if you're in the same journey as we are in. It's not an easy journey to implement this kind of target architecture where you also have a running business to do, right? We have critical business processes running on existing flows. So what did we see? We saw, first of all, the scope and size of the sheer volumes of data was beyond what we could actually handle. So of course we could buy another Teradata appliance, or we could we could install another Hadoop cluster, but at some point in time, it is not going to be more cost efficient anymore, we felt. It is not the only thing, there's more kind of triggers, but the fact that we expected more and more data to become needed, that was really something that was the first trigger. Next to that, we are desperately out of control of our data. So regulations, a bank is a highly regulated institution. We need to be able to explain where our data comes from. What are we doing with data? Which transformations are we applying to the data? All these kind of things we were not able to answer anymore because over the last years we have built up data warehouses and we have built up data flows, data marts, which were poorly documented, and we could actually not explain the answers to those questions anymore. So we had to do something there. Third thing, and I think that's where this whole day and this whole summit is about, you want to do more with data than you were originally used to do with data. So there's so much more value you can create with data, but you need to be able to access kind of the potential, and you have to have the latest technology at hand. So the innovative kind of value that you could create with data, we found we were unable to unlock with our existing setup. Our time to market became more and more important. That's, I think, more a IT story in general, but especially also for the data side, was really an issue as well. It took too long to really turn the data into value. And another IT aspect is also that we, as an enterprise, set a platform strategy. I'll get to that also a little bit into later. But the platform strategy also dictated a little bit how we wanted to move forward with the questions that were at hand. So two things that so you see all the triggers on the top of this slide, and we had to do two things. First of all, we had to create a new data platform besides the standing data or data flows and data platform that we already had. So we had parallel platforms because business had to continue to do their stuff. And the second thing is, once that was mature enough, we had to start to migrate our data flows into the target architecture and ultimately, like we said when we started off this presentation, kill our standing platform. So let me start with explaining how we build up the new capabilities. We started with the value in mind. So basically we started with the end goal in mind. And how did we do that? We created domain data stores, like I explained in a couple of slides before. Domain data stores are those environments where you can create the business logic and integrate the data in such a way that you're able to do the things that you want to do with. And there the value started to emerge. So it was fully cloud-based, so you see the obvious logos also in this slide. A cloud-native domain data store per domain. So imagine a domain like mortgages, finance and risk, functions where audit and risk and compliance type of workloads are being done. But also marketing domain data stores. I think we have identified as ABN AMRO now around 19 domain data stores, and I think we will consolidate that into roughly 14 data domains, and that is kind of mutually exclusive and collectively exhaustive. So that's kind of, we believe, given our current scope, that we can capture the entire estate of the bank data into 14 domain data stores. And with those domain data stores, we were able to, because they were already built on Azure native technologies, we were able to connect it to our analytics platform, also running on Databricks and with Azure capabilities around it. Plus, we were having Power BI on top of it. So the value started to emerge from our target data landscape and our domain data stores for the business. So, and in the meantime, we could also see that our engineers started to understand how you build a platform with those latest technologies. But still, the feeding of data into those platforms went through what we call legacy technology. So on one side, we were having our original data warehouses feeding data into our domain data stores, and on the other end, that was with Teradata. And we had a Hadoop platform on-premise that was collecting all sorts of raw data from data providers. So in terms of a target setting from an architecture point of view, that was already quite in line with what we wanted. So we wanted to avoid that we are going to integrate all our data into a canonical data model in our data warehouse. We wanted to just allow data owners to take ownership of their data, and because of that, we asked applications to provide their raw data in a meaningful manner to a Hadoop platform, and from there onwards we started to distribute that to our domain data stores. But our Hadoop instance was running on-premise. And our platform strategy was saying our data workloads, but next to our data workloads, actually as much as possible workloads that we have within the bank, applications and data flows, we want to move them to Azure. So that means that also an on-premise Hadoop platform for distributing data from A to B is, from a platform strategy, also not the desired way forward. So we suddenly were in a situation where we realized our data warehouse are not kind of the way forward anymore, because of the fact that nobody really understands anymore the business transformations happening into the data warehouse. The kind of business logic that over the years was built up, it was poorly described. Nobody could explain the lineage anymore and whatnot. So we had to first get rid of our data warehouses on Teradata, and next to that, our Hadoop implementation at the same time also had to move from on-premise to Azure. So it was quite an open heart surgery, I can tell you. And it took us ultimately, I would say, 4 years to really make that technical transformation on top of the design. But we have done that. How did we do it? For Hadoop and Teradata, we have actually built this data distribution platform on Azure. And what we did is we from the Teradata point of view, we have basically took the last, I think it was 3 years or so, to re-engineer all the workloads that we had in Teradata from scratch, but then on target architecture. So a lot of domain or data marts and tables and complete data flows had to be rebuilt by the various business lines. And that takes quite some time. Why did we push so hard for not migrating but re-engineering? Because by re-engineering, you basically repair all the issues that over the years have creeped into your data. So that was, I think, the most work. We ended up with a couple of workloads that from a timing perspective we could definitely not run. And we also found a solution in datometry to allow the last workloads to migrate away from the physical Teradata appliance. We lift and shifted those to Azure. And for the consumers of those data sets, it was hardly actually an issue for them because they could just speak as they used to talk to Teradata, but then behind an Azure, actually an Azure machine. So the whole workloads were moved to Synapse, and we built a kind of, together with datometry, a kind of virtualized layer around it so that the consumers hardly noticed any difference. Of course, there was a lot of testing required, but ultimately we could prove that the data coming from Azure was similar as what they were used to get from Teradata. So that was how we rebuilt it, or actually re-engineered mostly Teradata. For Hadoop, we actually created a parallel flow. So data providers were providing on a daily, weekly, monthly basis, quarterly even, their data towards Hadoop. Those were full snapshots of data. So files that were delivered on the Hadoop platform. And we created a kind of a mirrored flow, a forking solution where we also ensured that the same data was flowing into Azure. And that has, to build that forking solution, that took quite some time to properly test that and to run that and to make sure that that had the same performance and the same kind of, yeah, actually the performance was matching how it was in the previous setup. And only once we saw that that was matching, we could start to engage with the consumers and the providers of the data saying, hey, do you see the same on Azure as what you have seen on Hadoop? From a provider perspective, but also from a consumer perspective, because that's ultimately the proof of the pudding, of course. And that, I think, was done in 1 year. So we really did that also with a lot of help from Databricks technology to migrate away from the traditional data flows, ETL logic, and move that into Azure technology. Now, just to give you a couple of flavors around what are we talking about. So the Hadoop migration, that was petabyte volume. We had 150 source applications, providers that we had to migrate. We had around the same number of data consumers. I think it's currently close to 10,000 files or trigger files a day that we have to manage. And we currently have around 99.77% of first-time write processed files. Because you need to do some pre-processing to have it all in a Parquet file format landing on Azure. Teradata, also some numbers, also big migration. And we did see 2 months ago, we finally saw the pictures of this physical appliance being escorted out of our data center after 3 years of hard work. It was a nice picture. I should have put that in the slide, but for the people who want to see it, we have really done that. So I want to also talk a little bit about the platform strategy and the history, because we have embarked on a journey of going to the cloud, but we have learned some things the hard way. So I want to take you along a little bit on where we come from and what we have learned and where we are currently. So back in 2019, we said we were a company that had actually outsourced all the infrastructure to, by then it was still IBM. So our own data center was managed by IBM. And that meant that development teams, once they wanted to deploy something, they had to go to the IBM teams and they had to ask them to deploy it to production. And of course, that is not the biggest deal, of course, but if you want to, of course, bring in some new hardware, and especially when it was some niche kind of setup, it could take you roughly 9 months until you had even this new hardware brought in, installed, and you could deploy your new kind of deployment on your stack. That we thought we should do differently. So we wanted to really move into DevOps so that the teams that are building the software can also deploy it basically themselves and maintain it themselves. Now, in order to be able to also be a little bit untangled from IBM by that time, we said let's then also consider the cloud as another target platform next to our on-premise, because we did not choose to go fully into the cloud, but at least we said let's try to bring as much as possible, because then the teams can also start to manage their own infrastructure. That was back in 2020, and we chose a hybrid cloud strategy. For a bank our size, and I just explained the numbers, not a good choice. Don't choose for kind of a hybrid cloud setup. We had Amazon and we had Azure, and already from a data point of view, you can imagine how difficult it is if you want to have all the data accessible and you have multiple clouds where you have this data on. So we moved into a narrowed kind of platform strategy and a focused one, and we then became the Azure shop that we currently still are. But there was a kind of a view by then, and that I'm talking about 2021, stating everything outside the mainframe, ship it to Azure. Migrate it or rebuild it, whatever is best for you. Again, I think too optimistic, too ambitious, because there are workloads that, for example, require an Oracle database underneath, and shipping that towards an Azure setup is very difficult and also very expensive. So we are currently in a kind of a situation where we call it, our latest kind of iteration is a cloud smart strategy, where we really have a value-based approach. And if I now had to describe our kind of platform strategy, it would be we have our mainframe for our transactional workloads. We still keep it. It performs really well. There's really not yet an alternative that we think is right, or it doesn't weigh up against the cost. Next to that, yes, there are still a couple of applications that we believe should remain on our on-premise data center, because we believe it's too difficult yet to migrate that towards the cloud. And then we have a whole bunch of applications that we are migrating or have already migrated to Azure by either doing an IaaS kind of lift and shift, or a re-engineering using the latest and native Azure technologies. That's currently what we call the Cloud Smart strategy, and that was also a big driver behind our platform, or our data platform strategy. I'm going to hand over the word now to Rakesh. He's going to say a little bit more about how we're using Databricks in our setup, and also what our lessons learned were from the last couple of years.
Thanks, Marcel. So Marcel explained about our data strategy. I'm going to explain more about the usage of Databricks and how Databricks help actually us to move towards a cloud actually. So if you look at the usage of Databricks, we basically use in 4 different areas. We have very complex integrations, and we have 20 domain data store, we already explained. And those domain owns actually integrations. All we do on Azure based fully with the Databricks actually. Also, we are a small bank, but we have a lot of data. It's too much data to handle, and to process those data, you need a compute, and for that compute, all is provided by Databricks. We also have machine learning and MLOps models running actually, which helps bank to make certain decisions whether it has to calculate the risk appetite, or it has to do with the detecting financial crime. That's also basically runs on the Databricks. And then we also use Databricks actually as an accelerator for different purpose, like maybe it's a pre-processing, or sometimes we use utility like autoloader to move the data fast from one domain to another domain actually. We are also exploring some new tools of the Databricks, it was also announced in the morning. Unity catalog, Databricks SQL serverless, and see what value it's add to our bank. So that's already into an exploration phase. Databricks helps us a lot into our migration strategy, migration story, but it's not a silver bullet. So there are situations where Databricks helps, but we also have situations where there were a bit of challenges as well. So I will highlight some of the innovative solutions which we basically build during our migrations, where Databricks helps. So like our migration was a very large scale migration from on-prem to cloud, and we had almost 150 systems which provide data, and more than 150 systems consume data. And if you have an on-prem warehouse where you have connection to 150 systems giving you data and 150 consuming, if you move that platform on cloud, then you can see the impact on the whole organizations. And that's where some innovative solutions were developed, where we say, okay, we will not have any impact for provider or consumer. We just move the platform actually, and they work as it is. So one of the solutions was data preparation, where we do a lot of pre-processing. So we said, okay, you provide me data in the same format you used to do it. We will do a pre-processing and make sure we convert it to a Parquet. So that solution was built on Databricks. Another solution was we had some legacy tools actually, where we say, okay, they were consuming data into old Hadoop Hive tables, and when we moved to Azure, it was more about a Parquet. And then it means it's a change for consumers, where Databricks come up with external table and solutions where there was a zero impact for a consumer, and it's also helped us actually to move data on Azure without any impact for a consumer. We also used a utility like autoloader as well to move the data fast, because there is one thing important for our consumer is not only delivery of data, but timely delivery of data, because we had a SLA, we are a bank, and certain processes runs, let's say, before 6 a.m. in the morning, and if data is provided by provider, let's say 4 o'clock in the morning, so you have only 2 hours to make sure the data is available in the chain. So that's also important. So speed is also matters for us. There were some challenges with Databricks as well, or we can say Databricks should improve on this. One of the challenges I would like to highlight is a lack of a proper monitoring. So when it's come to infrastructure monitoring, Databricks is good. They can say, okay, this pipeline is there and it fails. It can create alert notifications. But when it's come to data sets, so when you want to basically move the data, when data is moving from A to B, you want to track actually, which is not possible at this moment. And that's where we had to rely on external or homegrown tooling actually, which is more nowadays called data observability actually. And I feel that should be a part of a solution and platform. You should not be building a separate one, otherwise too much. That's another I would like to highlight is integration with on-prem actually. Databricks works very well on the cloud, but we're a bank and our core process runs on mainframe. And you want to move data from mainframe to a cloud, it's really difficult. Then you have to rely on another tooling actually to bring data first into a cloud, and then you process it. And that's all add to latency actually, which you don't want. So these are some improvements as well, I think. I hope the intention of putting here is that in the next Data and AI Summit, we'll have those features already available. So let's see. And then I think our migration was very large scale and we had a lot of success, but we also have some lesson learned as well. And I would like to highlight here, so if you are in a similar journey, you can learn from it actually, and at least try to avoid that. So cloud is good, but you also need to take care of cost factor as well. Huh? You also need to see what is the initial investment you're going to make, or what is the value generation out of it. And for that, you need to have a proper governance, control, actually. You should not, if a job need a very small amount of, for data, a small amount of cluster, you should not be running a gigabyte cluster, which it's a waste of money, actually. So your infrastructure should be optimized well enough. So that's one part. Second is business continuity. These large migrations always actually started by IT, but I think it should be backed up by business, because there will be a phase where you need a buy-in from business actually to make it success. And another lesson learned was you should never start this kind of migration in the middle of the year, because you always, these are not an easy one, and you cannot do it in 6 months or 9 months, and you end up in a year-end reporting, and then you have a multiple platform. You don't know what the cutover plans are, how you're going to report it, and a lot of issues. So better start beginning of the year once your annual reporting is done. So that's the biggest lesson learned as well. Another is use your telemetry. So here, what we have seen is we had a couple of warehouse platforms. So like Marshall mentioned, it was Teradata, and we had a Hadoop. When we migrating, we initially make a mistake of defining the scope, actually. We should not migrate everything. You only move the relevant data to the cloud. And that's where you should use your telemetry to see how much data being used by whom, actually. And we later on use telemetry, and we kind of avoid 30% of the data not moving to the cloud, and we speed up our migration, actually. This is another lesson learned. Final one. One of the things what we learn is in the whole cloud journey and in whole domain-driven design approach, one team actually cannot do everything. The reason is we have multiple domain-driven team which required a similar kind of solution. So we said, let's combine together, create a blueprint, and then roll out for all the teams. And then it's also kind of inner source way of working, actually, and it also brings synergy among the teams, actually, and cooperations. So this was our biggest learning as well. Looking at time, I think I need to hurry up. We don't have much. And this is our end of our story. We are open for questions, feedback.